Walking through a forest, birds are flying, deer wandering, trees swaying. Arboreal acoustics act as audible sutures, stitching us into the spiderweb of interdependence. Hidden in this experience is an ever-growing organic network, an interlacing tessellation, silently swimming in the soil. Communing with this queendom of organism takes putting an ear to the ground to listen. In the Northern Pomo language, the phrase is shimama. I've always viewed the world through an anthropological lens, but felt the need for more people to do environmental work. Discovering ethnomycology, I found it to be an applied study of humans' relatedness to nature, especially those parts of nature that facilitate cyclical growth and impermanence. I believe fungi hold a key component for humanity's success on this planet, and yet the queendom of mycota has a habit of slipping beneath the surface and being forgotten about. My MEM project comes from a vision provided by the Potter Valley Tribe, or PVT, which acts as an intersectional link between fungi-related issues combining food sovereignty, waste diversion, community science, and ethnomycology. To kick off the project, we started working on a room to cultivate gourmet mushrooms, located on the Mendocino, California coast. The structure was a dairy from the 1940s and had little alterations, so we had our work cut out for us. We painted, added ventilation, installed new windows, added shelving, put in new doors, and did a deep clean. Much like humans, mushrooms grow well on cannabis, coffee, and beer waste. Based on previous research, mushrooms act as an efficient closed-loop crop because they can be grown on production waste substrates. We expanded on this through experimenting with growing on waste byproducts, such as spent brewer's grain, spent coffee grounds, hardwood sawdust, and spent cannabis stalks from our local businesses. We also experimented with different recipes and combinations of supplements and substrates. We processed the substrate with creative means, such as a weed whacker and a barrel to chop up straw, or a wood chipper for cannabis stalks. Next, we pasteurized it, purchased spawn from a farm in San Francisco, and then experimented using either plastic bags, biodegradable bags, or reusable buckets. We also used down logs, an abundant byproduct of fire restoration in the region, inoculating dowels with different species, which is a way to grow that is less intensive, but it takes longer. We then sit them in a place that simulates summer weather, so around 75 degrees, and the mycelium starts to run. We found that the fungi grew the fastest with the cannabis, which is great, as Mendocino County has a plethora. After a period of 2 to 6 weeks, we take them to the fruiting room. From there, it only takes a few days for mushrooms to appear. Over the course of this project, we have cultivated 6 varieties of oyster mushrooms, 3 Pleurotus austratus, Pleurotus gemor, Pleurotus citronoplateus, and Pleurotus erengii. We cultivated lion's mane, Hericium erinaceus, shiitake, Lynchinula edodes, Nemeko, Pholiota microspora, and cinnamon cap, Hyphiloma subpluteridium. We wanted to use as little inputs as possible to make the project more sustainable and efficient. The average humidity and temperature on the Northern California coast would normally maintain a mushroom farm, but this year we had an unprecedented lack of rain. To give context, the last time the region had no rain in February was 1864. This was after a very wet year of 2019, so farming conditions are getting that much more unpredictable. Because of this, we invested in a heater, humidifier, and recording device to maintain an average temperature of 60 degrees and humidity of 95%. Fortunately, the extra energy it takes to run these machines is offset by the tribe's solar system. After the adjustments, the mushrooms began to look better. For harvesting, when growing them in buckets, we just pop the clusters off. For mushrooms that need to grow in bags, you cut them with a knife like you would harvesting in the wild. So far, we've grown around 40 pounds of mushrooms, with more popping up every day. And of course, we turn these mushrooms into food. And we also dried them to make mushroom medicine. After the mushrooms have stopped fruiting, which is around 8 weeks, we put the spent blocks in our on-site compost pile, which is then used for the tribe's medicinal native garden. Throughout mushroom gathering season, the tribe goes on forays to find choice mushrooms. These include candy caps, which is a sweet mushroom, black trumpets, hedgehogs, dead man's foot, which is used as a natural dye, as well as forest finds like flicker feathers, used in regalia. This is an expression of ethnomycology, or people's relationships to mushrooms. Ethnomycology is vital to the field because it is what strengthens our connection and furthers fungi research. After consultation with the PVT Council, we decided to hold an integrative mushroom workshop in early March, open to regional tribal members, hosting a blend of cultural and environmental knowledge sharing sessions in the clubhouse at No Yobita Ranch. The topics we discussed that day included medicinal species and their benefits, cooking techniques, personal gathering experiences, soil remediation and composting, knowing your sources, gathering rights and potential policies, iNaturalist and Microflora project, and a presentation on PVTs grow from local waste substrate. We had 24 attendees from 7 different tribes with youth and elder representation. The lunch included mushroom dishes created by a local mushroom chef, with medicinal teas, casserole, stew, dips, salad, and 2 desserts featuring choice mushrooms such as chanterelle, boletes, candy cap, and oysters from our grow project, as well as traditionally gathered seaweed mussels and salad greens. During this workshop, we planned how we want to move forward as a group to include mushrooms into tribal environmental and cultural efforts needed to remember how vital fungi are to our health and well-being. In early 2019, I established a project with the North American Mycoflora Project across the ancestral territories of the Northern Pomo. Using iNaturalist, we were able to map mushrooms in the pine forests at No Yobita Ranch starting January 2019 to March 2020, using the NAMP identification sheets as practice. Throughout the year, we collected local specimens that we were interested in sending to NAMP to have DNA sequenced and eventually be able to cultivate them. Unfortunately, we learned NAMP ran out of funding partway through this project. Consequently, our direction was changed, and alongside PVT's maintenance department, we decided to plan for a mushroom path on the property featuring local mushrooms. Using GIS software and iNaturalist data, I created a map to best identify and lay out where the path should go and which mushrooms will be there. We plan to forward our ethnomycology data with our NAMP project to include traditional knowledge as we move forward. At the end of March, we were approved for Western SARE grant funding to expand the project. With the grant, the tribe will construct their own cleanroom and lab area to create spawn instead of having to purchase from a distributor. We will also be able to isolate native species this way, cultivating species form fit for the environment and re-indigenizing this process. In addition, we want to expand into farmers markets and online retail selling mushrooms as food and as medicine. The tribe is starting up their own coffee shop later this year, and we plan to use the coffee waste in the mushroom production and in turn use some of the mushrooms we grow and gather at the coffee shop itself, effectively displaying a circular economy mechanism. We found from discussions with people that showed up at the workshop that we need to connect the local mycology enthusiasts with the mushroom medicine makers and local tribes and fortify gathering rights. We also found that the environmental departments within tribes are interested in adding mycoremediation to their ongoing land restoration, which includes using specific fungal introductions for leaching in landfills and using fungally inoculated biochar to remediate soil. As with the mycelial network underneath us, connecting the roots and nutrient systems of forests, it is vital to weave a network to continue cycling feedback in order to grow regeneratively. This project revolves around renewal, inviting people, and especially Native youth, to continue traditional practices and projects. Culture is not stagnant, and just recording does not preserve it. Knowledge is transmitted through generations by living the practices, and this project functions as the mushroom inoculant to do so, branching out in many different directions, like the mycelial web beneath us all. I'd like to thank my MEM mentor, Taryn Mead, the Potter Valley Tribe, and the countless volunteers that helped actualize this project.